Alright, so good morning. So today we're looking at the Leadership College. In this video, probably up until question 4 or 5. So let's get started. It was the Leadership College in November 2016, paper 1. It was a 2-hour paper for 100 marks. Okay. So there's 4 instruction points there. Very important. Read through them normally. I'm not going to read through them now. So in question 1.1 we are told factorize completely. Okay, so to factorize completely, as you can see there's 4 terms. There's factorization by grouping. So I group the first 2 and the second 2. If I group here, I take ax out as a common factor. I'm left with x squared minus 1 plus ab, which is a common factor, x squared minus 1. Not so. What is now common? X squared minus 1. A is also common, but you can take it out in the next step. What can be done on the first bracket? X plus 1, x 1. What do we call that? Difference of 2 squares. And this here? Common factor of a. So it's going to be x plus 1, x minus 1. A is a common factor, but I never write it there. We always write the coefficient in front, so it's a, and I'm left with x plus. Okay, any confusion there? No. Just let me know also where did you make a mistake, and then I can explain what would have happened or where you would have lost your mark. Okay? Or if could have even be right. Okay. The next one. What can happen here? Difference of cubes. So what's the cube root of a to the 6? A squared minus 2b. So what I do is I first square the first term, gives you a4. For the middle term, that is minus. So I must have a plus. That times that. It's going to give you 2a squared b plus the last term squared, which will be 4b squared. People, this will always be a plus. Okay? Any confusion here? Right, next. In question 2.1.2, simplify. So you must find an LCM and add numerators, not so. So, before I do my LCM, what must I do? Factorize this here. Otherwise, the others are already in simplest factor form there. So it will be 2 over a plus 3 minus 21 over trinomial a minus 4 a plus 3. What's my LCM at this point? A minus 4 a plus 3. Put that over a minus 4, a plus 3. So what must this be multiplied by to get the LCM? A plus. So it's 3 into a plus 3. What must that be multiplied to get by the LCM? A minus 4. So it's 2 into a minus 4. What must this be multiplied by? Nothing. 1 can't be nothing. Nothing times 21 is 0. It's nothing. Alright, you all agree with that? Now what do? We multiply. We want to add to simplify the numerators. So that's going to give you 3a plus 9 plus 2a minus 8 minus 21 over a minus 4 a plus 3. Now what do? Like terms. So that's going to give us 5a is minus 20. Okay. Now there's another step that's going to follow, so I'll take this a bit down. So you're going to get 5a plus 20 over minus 20, no problem. a minus 4, a plus 3. Now what? Common factor of 5. You know what am I left with? Over a minus 4, a plus 3. What's going to happen now? Cancel. So it's going to be 5 over a plus 3. Any confusion here? You all okay with that? So far so good, you would have bagged all those marks, no? Let's see, no? You'll find out. Right, next. What needs to be done first here? Basis, no? You're going to write it in products of its prime factors. Products of its prime factors. Okay. So 4 can be written as what? 2 squared raised to the 2y minus 1 times 9 can be written as 3 squared y plus 1 over. Now 18, we know it's going to be 2 times 3 squared. Say we didn't know that. Okay. Just close this and reopen it. Calculator. Alright. So say we didn't know that, we say 18 is equal shift factorize. As you can see this button here with the dots on. So it's 2 times 3 squared. It's 2 times 3 squared raised to the power y times. Same thing, 8 can be written as 2 cubed y minus 1. So what do I do now? Multiply the exponents. Not so. So it will be 2 to the 4y minus 2 times 3 to the 2y plus 3. 2. Okay? That's a common way to error there, no? If people write a 1. I almost made the same thing, same mistake. They say, I'm glad you're here. Okay. You're going to correct me. Over 2y times 3 to the 2y times 2 to the 3y minus 3. You all agree with that? Now what? When you're multiplying it, bases are the same. Add the exponents. So it will be 2 to the 4y minus 2. Remember, only the ones that has the same basis can be brought together. Only those exponents can be brought together. And only when you're multiplying and dividing can it be brought together as we're going to do it. If there's a plus or minus sign between it, you cannot do what we are doing now. Okay? So it's going to be 4y minus 2. Remember, this is in the denominator, so I'm bringing it up. So it's minus y. It's also in the denominator, which I'm bringing up. Becomes minus 3y plus 3. Times 3 to the 2y plus 2 minus 2y. So what do I do now? Like terms. So 4y minus 3y on. What's minus 2 plus 3? 1 times 2y minus 2y is also cancel. So it's 3 squared. And 3 squared is 9. How can it be 4? And 2 times 9? 80. Any confusion there? No. Yes, on that side? You guys okay? Alright. Think I'm sleeping? I'm going to just write down what you tell me. Alright, next. If x squared plus 1 over x squared is equal to 3, calculate the value of x plus 1 over x all squared. So one of two things I can do. I can either work with that first, or I can work with this one. I'm going to go with working with the one in the bracket first. It's going to be easier. So this is a binomial square. Now, if you're a person who always get this multiplying the binomial square out, and you're getting it wrong, always write it out twice, and you multiply the story out. Okay? If you can't do that, the binomial square step, don't keep yourself brave, people. Do that. No? Your friends won't know that you're doing the long method. Okay, we will just think, okay, there's something wrong with this child. But it's okay. No? But nobody's going, other than us, going to know that you did. And you're going to get the mark for it anyway. Alright? But I know how to do it. So you square the first term, gives you x squared plus that times 2. So it's x times 1 over x, which is x times 2 is 2, plus the last term squared, which is 1 over x squared. Let's say, hang on. X squared plus 1 over x squared is what? 3. Not a O, it's a, like I'm just highlighting. So it's going to be 3 plus 2, which is 5. I can't believe it's so easy. No? Micronizing? We upset it's so easy. People, let's look at number 1.4. Consider the following numbers. The square root of negative 8, this is undefined. That is going to give you negative 2. And this is going to be 2 root 2, which is a third. Alright, let's see. Which of the following of these numbers is irrational? So which number is irrational? Square root of 8. Non-real? Square root of negative. It's actually non-real and not undefined. Okay, undefined. When is something undefined? Yes, when is it undefined? When the denominator is equal to 0. Like if you got 5 over 0, this is when it's undefined. The square root of a negative number, that is non-real. Okay, do you guys understand? Right. Let's go with number 3. Show that the sum of 3 consecutive even numbers is a multiple of 3. What are consecutive numbers? Numbers, yes, that follow each other. Not so. Now one number after the other. Not so. So if I start with 20, what are the consecutive numbers? 21, 22. If I start with 506, 507, 508. Those are consecutive numbers. What if I had started with x? It's just one more. And again one more. And so on. Not so. So we are told that, show that the sum of, what does sum mean? Added together. Not so. Show that the sum of, so it was the sum of 3 consecutive even numbers. I didn't read so far. So, go again. So if it was 506, it would have been 508, 510. It's 1063. No. 630, yes. It will be 10,632. 10,634. So even consecutive numbers, I'm adding 2 all the time. So the first number is x. The next one is going to be x plus 2, then x plus 4. Those are the sum of the first 3 consecutive even numbers. Okay. If you wanted, you can put a 2 in front of the x. Okay? A 2 in front of x, but it's not going to make any difference. Okay? For it to be a multiple of 3, so for the sum, we're going to add it. So what's x plus x plus x? 3x. 2 plus 4? 6. So what do you notice? We got 3 as a common factor. Not so? And 3 multiplied by any number, provided that it is now a natural number. They had to say here, what I had to say? Show that the sum of 3 consecutive integers or 3 consecutive natural numbers is multiples of 3. Can you see that? Because if you're looking at 2, 5, if I use 2, 5, oh no, sorry. By saying even numbers, we have already eliminated that story. Okay? I was thinking of something else now. I was trying to be technical now. So what do you notice here? 3 is a common factor. Not so. So in conclusion we say since 3 is a common factor, therefore will always be a multiple of 3. Therefore the sum of 3 consecutive odd numbers, even numbers, will always be a multiple of 3. Does it make sense? No? Doesn't make sense. Why doesn't it make sense? Why, what part don't you understand? What?
Sir, I said 2 plus 4 plus 6.
2 plus 4 plus 6. But you see, the thing is, you can't say it's 2, 4 and 6 because I didn't tell you that's the numbers. So you must prove generally that it will work. So if you said x is 2, 2, 4, 6 years, but I could have said x is 100. She could have said x is, she only have 4 people in the micronation, or 3, or 4, let's say 4 because it's even. So it's 4, 6, 8. You understand? So you can't choose values, you must be, you must use algebra to represent any number given. You understand? Alright. Let's look at question 2. The question says solve for x. Alright, so what do we do first? We write it in the standard form. And what's the standard form? ax squared plus bx plus c equals 0. It's a quadratic formula. Not so? So what do I do is I take the 11 over. It becomes 6x squared plus 11x minus 35 is equal to 0. So what do we get here is a trinomial. So I must draw my product line. Okay? So it's going to be 1 and 6, 2 and 3. That's the factors of 6. Factors of 35, 1 and 35, 5 and 7. Do we add or subtract our products? Subtract. Why? Because the 35 is negative. So 35, 1 times 35 is 35. 1 times 6 is 6. It's going to give you 29 if you subtract. That's going to give you 30. Minus 7 is 35. No. 30 minus 7 is 23. So that's going to give us 70. That's too large. That is 14. 14 minus 15. Right. So this is not going to work for us. Not so. So what do I do? Swap. So we can swap one of the two sets around. I'm going to swap the left hand. I could have swapped this. There may no difference. Okay. So it's going to be, that's fairly large. That is going to be 42. It's also very big. 3 times 35 is large. That's 21 and 10. Not so. What's 10 minus 21? 11. So in other words, it's a 3 and a 5, a 2 and a 7. A 3 and a 5, a 2 and a 7. There's an x squared, so there goes an x and an x. What about our signs? 1 plus 1 minus. Also, The bigger one has to be plus. The bigger one always take the sign of the middle term, bigger product. So that is 10x and this is 21. So of course 21 is greater, so there goes a plus and a minus. Does it stop there? No. What do I say now? 3x minus 5 is equal to 0 or 2x plus 7 is equal to 0. People, I know there's more than one way of working this out. Okay? If you find a better way to be, another way to be more simple or easier, by all means go with that way. Okay, so we take this over, becomes 3x is equal to 5 divided by 3. So x is equal to 5 over 3. You all agree with that? Look at the next one. Take 7 over, so 2x is equal to negative 7. Divide by 2, so x is equal to negative 7 over 2. Okay? Any problems here? No? Let's look at the next one. This is your exponential equations. So the idea is here to get the bases the same for the exponents to be equal. Basis needs to be the same for the exponents to be equal. So 81 can be written as 3 to the power of 4. So is this basis the same? No, that's a numerator and that's a denominator basis. So I take it up, becomes 3 to the x is equal to 3 to the negative 4. Now what? Therefore x is equal to negative 4. Okay? You all agree with that? The following inequalities is given. The following inequality is given. Solve for x in the inequality. So there's a two-way inequality, a double barrel. No? It goes two ways. So in other words, I will take the 3, so we got negative 1. To read the sum, it will be 3x minus, not 3x, 3 minus 2x is greater than or equal to negative 1. We always read the left first. And 3 minus 2x is less than 5. So to solve this, I need to get x on its own first. So the 3 goes both ways. Because it's a 2 in 1. If you want to write it apart, it would be negative 1, 3 minus 2x, and, because that's together, 3 minus 2x is less than 5. If you want to write it apart, that's what it's going to be. Okay? But we don't have to write it apart. So it's going to be negative 1, this 3 take over becomes minus 3, as we do in an equation, and it's going to be 5 minus 3. So negative 2x is greater or equal to negative 4 and 2. So what do I do now? Divide by negative 2 both sides, throughout. And then the inequality signs will change. Under what condition does it change? When you either divide or multiply by negative. That's the only time the inequalities will swap around. So then this should be 2x negative 1. You all agree with that? You can leave it like that, or you can write it as in the proper form. As we know, the smaller one will always be on the left. Okay. You don't have to. We are giving you full marks at this point. Okay. But that is the correct way of it. In the next question, in question 2.2.2, represent your answer to question 2.2.1 on a number line. This must be on a number line. Okay? So you look at the number line. What are your critical values or important values on this line? Negative 1 and 2. Okay? Okay, so these are critical values or important values on this line. Okay, so at -1, would it have an open or closed circle? Is that inclusive or exclusive? It's exclusive. So we would have an open or closed circle? It will have an open circle. The 2, closed circle. Can you see that? So we say x must be greater than. If it's open to the x, it's greater. So x must be greater than, or if you read from the side, x must be greater than -1. Just going in the positive direction. However, x must be less than or equal to 2. And there we go. Both conditions must be met. Okay, and when it overlaps is my solution to the sum. Okay. Question 3. Let's see through for some reason. Question 3. We are told that study the following pattern made up of sticks. Pattern 1 have 8 sticks, as you can see here. 1, 2, 3, 4, 5, 6, 7, 8. Here's 8, 9, 10, 11, 12, 13, 14, 15, and so on. Okay, you all okay with that? You know how to count sticks, no? Yes? So the question says in 3.3, I think 3.1.1, how many sticks will there be in pattern 4, or the 4th pattern? So if you look at the sum here, we have 8, 15, 22. So you say, okay, how do you move from one to the next? You added 7. You're adding 7. So in other words, I have to add 7 again. 22 plus 7 is 29. So therefore pattern 4 will be 29 sticks. Are you all okay with that? Or T4 for term 4. Then the question says, write down a conjecture that describes the relationship between the pattern number and the number of sticks required for the pattern. So in other words, if we take this pattern into account here, so the conjecture is basically your general term in words. Okay? So the conjecture would be, you'll start off with 8. Okay? Start off with 8. Then add 7 to the previous term. So which means to say if you start off with 8 and then add 7 to the previous term is going to be 8 plus 7, which is 15. Add 7 to the previous term is going to give you 22, and so on and so on. Does it make sense? So we we're starting off the point we're starting off at, and what we're adding or subtracting all the time, which is your common difference. Does it make sense? Okay, so you write that in words. As you said, your conjecture is basically the general term in words. Then for 3.1.3, question 3.1.3, we are asked to write down an algebraic formula for the number of 6 in the nth pattern. A formula for the nth. In other words, I could ask us to work out the general term as well. Not so? So the general term will take the form of what in this case? Tn is equal to? A plus n minus 1b. No? Did we work with this formula already? Yes. So what's my first term? 8 plus n minus 1 times 7. Because 7 is your common difference now. You all agree with that? So you multiply this in, I get 8 plus 7n minus 7. So it's 7n plus. That's my general term. Any confusion? Right? In question 3.1.4, okay, and I want to move the next one down because of the space I have left for the sums. It's catching up to us now. So we are told which pattern will use 351 sticks to build. So in other words, if you extend this pattern, I just took off from the board now. You started with 8, then 15, then 22, then 29. If you extend this pattern, it will then cross 351. Can you see that, people? They want to know which pattern will use 351 sticks to build. So in other words, this is your nth term here. Not so? You all okay with that? So we then say, if Tn is equal to 7n plus 1, but Tn is 351. Not so? I can drop this. So 7n is equal to 351 minus 1. 350. So I divide by 7 both sides. So n is equal to 50. So therefore, it's the 50th pattern, pattern 50, will be equal to 350. Any confusion? You all okay with this? Okay. You guys get it right?
Yes.
Okay. So in 3.2 we are told the ACA was revising for examination and came across the following sequence of numbers. Write down the next two numbers in the sequence. So how do I get from 2 to 4? Multiplied by 2. 2 to 8 times 2 times 2. Not so. So 16 times 2 is 32. And 32 times 2? 60. What type of pattern is this? Is it linear or arithmetic? It's arithmetic. When you add or subtracting the same number all the time, that is arithmetic. So we're multiplying all the time. So it's a geometric. It's a geometric pattern. Okay? Write down an algebraic formula for the nth term of the sequence. For a geometric pattern, have you done geometric patterns? Yes, in grade 9. Do we do this here as well? Yes. So what is the formula for a geometric pattern? A is times, not plus, R in minus. You don't know? Okay, sure, okay. It's fine, listen. Relax your bones. Okay, say you didn't do this. I'll show you firstly where this fits in. So A is what? The first term is 2. R is what you're multiplying it by, which is 2 n minus 1. That is your general term. You could simplify this into 2 to the n as well. So you're multiplying it by the same you are in the powers. But they will have given you a full 3 marks already. That's how you didn't know this. They just say you got 2, 4, 8, 16, 32 and so on. This is 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5 and so on. Not so. What is your n in this term? In this case, 1. What's your n here? 2. Your term number here? 3. Term number? 4. Term number? 5. So in other words, the general term here would just be 2 to the term number, which is 2 to the n. Okay? So if you didn't do it, no problem. You should have been then able to figure it out from here. Okay? Then the next question says, calculate the 20th term of the sequence. So how do you calculate the 20th term? So if Tn is equal to 2 to the n, then t to the 20 will be 2 to the 20. And 2 to the exponent 20 on the calculator, 2 to the exponent 20 is 1,048,000. 1,048,576. That's the value of the 20th term. Right, you guys understand?
Yes.
Right. Then the next question, question 4. In question 4, we are given f of x equals x squared minus 4. So what type of graph is that? Parabola. And g of x equal to negative 2x minus 4. Which type of graph is that? Straight line. So the question says sketch the graphs of f and g on the same system of axes, showing all intercepts with the axis and the relevant turning points. So for f of x, we know firstly the graph is positive, so it's smiling, yes. Then x-intercept, what we do? We get y equal to 0. F of x is a y. So 0 is equal to x squared minus 4, difference of 2 squares. So x plus 2 is equal to 0, so x is equal to minus 2. Or x minus 2 is equal to 0, so x is equal to plus 2. Or vice versa. Or I could have taken it the other way around and said x squared minus 4 is equal to 0. So x squared is equal to 4. If I introduce square root, what must I not forget? Plus minus. So x is equal to plus minus 2. The same thing. Okay, not so? Thereafter, we work out our y-intercept. What do you do for y-intercept? Let x equal to 0. So that will become 0 there. So f of 0 is equal to 0 squared minus 4, which is negative 4. So that is enough information to draw that graph. So it's going to cut that minus 4, negative 2 and 2. It's all by approximation. Can you see that? But if that is a negative 2 here, you see that's about the same? So if negative 2 lies there, by approximation, the positive 2 will never be there. Can you see that? Just more or less. Okay. So we know the graph is smiling. So we draw from the turning point up. And there we go. And this is the graph of f. There's more than one equation or more than one graph on the system of axes. I must name it. You all okay with that? Let's look at the g of x graph. For g of x equals minus 2x minus 4. Does the increasing or decreasing graph? How do we know it's decreasing? Because of the negative 4, correct? No. Negative 2. The negative 2 is what was? Our gradient. The slope of the graph. The gradient is negative, the graph is decreasing. So we say, x-intercept, what do we do? Let y equal to 0. So 0 is equal to negative 2x minus 4. So x equal to negative 2. So that goes there. Y-intercept, what do you do for y-intercept? Let x equal to 0. So g of 0 equals negative 2 times 0 minus 4, which is negative 4. You all okay with that? Okay, and then the graph will come through like that. That's your g of x graph. You all okay with that?
Yes.
Any confusion? No. Alright. I'm taking this off here so that I can keep the graph in focus. First question 4.2 says, use your graph to determine the value of f, the values of f, if f of x is equal to g of x, so g of x equal to f of x. So, where they equal to each other is where they intersect. Can you see that, people? They intersect there and here. Not so? So what are the x values? X is equal to negative 2 or x is equal to 0. You all okay with that? Then, let's take this off. Then, they want to know where is f of x less than 0. So in other words, where is f of x negative? Not so? Or where is f of x below this line? Less than 0 means say negative. Not so? And that is of course positive. So is f of x, is the red graph, is f of x negative here? No. Is it negative here?
Yes.
Till here? And here? Yes. And there? No. Is this a continuous or a break-in solution? It's all together, it's continuous, so I write it as 1. So I say x has to be in that direction. X has to be more than negative 2, but x has to be less than. Okay, any confusion there? No? Let us go fetch 4.3. 4.4, should be a 4.5. Alright, so let's take this off. Just trying to keep the diagram again in focus so that it is not, you can see the diagram, okay. How can you use the graph of g to obtain the graph of h of x, which is negative 2x plus 4? So, say we didn't know about the translations and all of this. If you're looking at the g of x graph, this g of x graph was g of x equals negative 2x minus 4. No? What do you notice from that graph to that graph? How can you use it? So it's actually g is going that way. How do you move from g of x to h of x? Shift in the graph 8 units up. So say you didn't know that. So what you would have done was you would have drawn the h of x graph. You could have seen the h of x graph would be about the same, it would be exactly the same gradient, but cutting at 4 there. Can you see that, people? You could have seen the graph is shifting for 8 units up. Doesn't need to finish this quickly. So we can. So the answer to this is graph shifts. G of x shift for 8 units up. Okay, let's look at 4.3, 4.4. In question 4.4, the question says determine the equation of m if m of x is a reflection of f in the x-axis. What's the rule if it's reflected in the x-axis? Right, reflect in x-axis. The rule says y becomes negative. So it's a reflection of f. What is the equation of f of x? Was x squared minus 8, no 4. Was it that? You sure? Right. So if y becomes negative, that is a y in other words. Not so. So it's simply negative y is equal to x squared minus 4. So I divide by negative, so y is equal to minus x squared plus 4. And it's a graph of m of x. So I put that m of x in. You all okay with that? And the last question here. The last question we are told, determine the value of the values of a if f of a is 32. But remember, what is f of x? F of x was x squared minus 4. So in f of a, so if I see x, I put a a. So f of a is going to be a squared minus 4. But f of a is equal to, according to this, what is f of a equal to? 32. Can you see that big? So if you drop this, so a squared is equal to 36. Square root thereof, if I introduce square root, what mustn't I forget? Plus minus. So a is equal to plus minus. Okay, any confusion? Okay. Listen, for the next video, I'll probably do it tomorrow, you guys. So I'll send you the link sometime tomorrow. Enjoy the rest of your day. Good morning, class.